Hello. In this example, we're going to graph f of x equals x plus 2 cubed times x minus 1 squared. In this type of problem, we don't need to find all the possible rational zeros because we can just see them by looking at the problem. So the first thing we're going to want to do is figure out our table, the zero, the multiplicity, and the behavior at the zero. Now in this problem there are only two zeros. The first one is -2, the second one is 1. Now the multiplicity for the -2 is the exponent there, which is 3, and the multiplicity for the 1 is 2. And because it has a multiplicity of 3 for the -2 here, that gives me that it crosses, and the multiplicity of 2 bounces because it's even. The next thing we want to look at is the y-intercept. To look at the y-intercept, I want to look at f of 0. So that means you plug in 0 for all the x's here, and that's going to give me 0 plus 2 cubed times x minus, not x minus 1, 0 minus 1 squared. Then you simplify. 0 plus 2 is 2, so that's 2 cubed times -1 squared. 2 cubed is 8, -1 squared is 1. So that just gives you 8. So your y-intercept here is 0, 8. Fantastic. Okay, the next thing we want to do is we want to find the end behavior. To do that, we're going to look at the multiplicities. Add them up. 3 plus 2 is 5. So this is a degree 5 polynomial. And because the leading coefficient out here is positive, that means as it goes to the left, it goes down. As it goes to the right, it goes up. Fantastic. We're ready to graph now. So plot the 0, -2, and the 0, 1, the -2, 0, and the 1, 0. Then plot 0, 8. The end behavior means that after the last 0, the function is going down to the left and up to the right. Now, let's look at the -2. It crosses, but it doesn't cross in a linear fashion because its multiplicity is 3. So here, you should make it kind of look a little bit cubic. Okay, so if you were to kind of zoom in here, that kind of looks like a cubic function. It'll go up, crossing the 0, and then down to here, and at the 2, it bounces. So it's going to look a little bit quadratic at that point. And then just kind of connect everything. There you go. Now, just to kind of show you what it looks like in the calculator, if you take your calculator and type this in using parentheses, x plus 2, close parentheses, caret 3, make sure you use your right arrow if you need it, parentheses, x minus 1, close parentheses, squared. And then of course press zoom 6 or just press graph if you know it's on the standard window. There you go. Now I'm going to go ahead and zoom in here. Notice that this right here kind of looks cubic, which is the reason that if you look at a graph like this, you know that its multiplicity is greater than 1. And the same thing here at the 1, you see that it's bouncing. Now, you can't guarantee that it's bouncing unless you zoom in a whole lot here, but it looks like it bounces. So that's a good possibility that that is a multiplicity greater than 1 as well. I just kind of wanted you to see what seeing a function on the calculator can look like when the multiplicities are greater than 1. Alrighty, well, I will see you next time. Have fun.